Hello and welcome back to this Polish car price prediction set from Kaggle. We're on the EDA section, so let's start off by checking for some null values. So we'll go df.isNull parentheses dot sum. Now this will sum up all of the null values in each column and give us a nice little printout. And you can see here that we have some null values in our data set right here. Okay, so let's get started. So let's start off our 5-point distribution. So let's start off our EDA with a very simple function. So dot describe. And this is just a really handy data set. You can see here though, this is one of the downsides is we got the numeric column. So year, mileage, engine, and price. And so this is a nice, you can see that the minimum year is 1945, the maximum is 2022, and it gives us a good idea of the skew to the data because we can see here the minimum is quite a far away from the 25th percentile. Then this would mean there's a big left skew on this distribution. And we can learn lots of things from this, but it doesn't give us all of our data set. As we've seen, lots of our data is objects. And so what we can do is dot describe, and we want to go include. So let's go include objects so that we get a better sense of all of our data here. Ooh, and let's spell include correctly. And here we go. So you mark model, generation, fuel, city, and province. And we look at objects and dot describe. It gives us the number of unique variables. So this is really interesting in that model is not a very good feature to make categories out of. It's 328. So there's a large number of different models, and to create one hot encoding from that would be quite long. But fuel is a better category as there's only 6 different types of fuel in that data set. Okay, so we can see that fuel has 6 categories. Mark and province both have 23. So there's a possibility of using them in one hot encoding to get dummies, but 23 is quite large still. Important to note that nonetheless. The rest of the diverse, it wouldn't work well for one hot encoding. So you can see here where we have 328. In city, they have 4,427. So there's a large amount in a diverse group, and there might be some things that we can do to refine that down a little bit before we would want to use that in one hot encoding. And that would likely involve quite a bit of research. Okay. So categories. So let's start our univariate analysis, and we're going to look at the categories. So what we wanted to do, we specified province, fuel, and mark could potentially be used as categories, but they were objects as we saw up above. So what we want to do is for cat in categories, we want to do df.cat equals to df.cat. Now what this is going to do is go for province will be cat, so df province is equal to df province dot as type, and what we want to say is this is a category. And so we'll run this loop and we'll change the province column, the province series to a category, the fuel series and the mark series to a category. And we can do this and we can double check this now. We go df.info. And you can see here that we get category. So this is a much better way to work with data. It saves a lot of memory when we're working with the data. We can see here that our memory use is a little bit smaller. But in the sense, we just wanted to keep this organized so that we can iterate through this in the proper way. So what we want to start doing here is we're going to look at the features that we want to do in our in our univariate analysis now that we've cleaned them up. So we go df.columns, and that gives us a list of our columns. It's really easy to use copy and paste here, put it down here. So now we have we have a list of our features, and we're going to do a little bit complex loop. So I have some of it saved from before. You can see here there's 2 parts here. So there's the feature, and we're going to do just a regular pandas plot, and then you can see another feature we're going to do count plot. So this will really depend on which feature will allow us to do which type of plot. So a histogram is good for a numeric feature, and a count plot is good for our categories or object features. So let's do another for loop. So for feet in features let's do if df dot feet dot data type, so d type, is equal to, so if we want this to be a numeric, so what are our numeric columns up here? We can see that they're integers. And so let's go, if it's equal to int, we'll do this. And so we'll see here, we can see df.feature, make sure I'm spelling everything the same, and feature. So we can see here that I'll do df.feet equals int. And when that's true, I'm going to go df_feet plot that one. So I'm going to plot the feature. So for mark, mod, I'll plot it. And then I'll give the title of the feature. And I'm going to rotate the labels on the bottom axis a little bit to the left, or so I guess a little bit down. So they're a little bit clearer because some of these titles were a little bit long. So X, and then we'll show that plot. And then what we're going to do, we're going to do a second part of this statement. We're going to go, if that's not true, so else if that is equal to, so df feet is equal to category, we'll do this one below, so count plot. And so you can see here, and I just changed the spelling, make sure everything's accurate. So we have feet, feet, feet all the way through. Short form for feature. So if feature is an integer, we're going to do a histogram, and if feature is a category, we're going to do a count plot. So this will work out nicely. Run this right now. Oh, and just gotta make sure that we run the cell above where we define the list, and then we can go here. And we also need to make sure that we're defining our if statement correctly. So dot d type. D type is equal to category, not the feature equal to category, but we want the data type equal to category. And so let's run this now, and we can see here we get a nice little plot and plotting out all the colors, and we can see, I'll leave this to you to go through every one of these individually to not waste your time. But this gives us a very good distribution of all the plots, and we can see things here. This is why we rotated the graphics by 60 degrees to give us enough room to really understand that the Mercedes is the low features right here, and Mitsubishi is this higher one right here, and then Nissan is this tallest one right here. So we wouldn't be able to see this if we didn't rotate the labels. So it can be really handy. And here are my observations of what I noticed. Make sure you go through them and make sure you understand why I said what I said. And do you agree? Do you disagree? So let's head into the bivariate analysis next.